All right, hello everyone, this is Mr. Crozier. I wanted to give you some help on our extra credit project. It's due on Monday, but this is the monthly temperature sine functions. And what you're going to be doing is selecting a city and researching the average monthly temperatures. Then you're going to create a graph and on paper and on Desmos about your the data that you found. So right here's the basic format. You can pick a city and a country, and you're going to write a final equation. And we know that our final equation for sine is y is equal to a sine bx minus c plus d, all the different parts that we've done. And you're going to be able to find the amplitude and the midline of your graph, and you're going to use Desmos, the graphing calculator online, to find these two values here. So kind of keep that in mind. You're looking for this equation. We can calculate this, we can calculate this, and these last two values you'll find out using Desmos. And we'll do that. I'll make another video for that. But here's an example project that's done that's already in the classroom. And what I did is I researched Huntington here, and I found an equation for the temperatures in Huntington. If you take a look at the monthly temperatures, and you can Google this or find this anywhere online, in January it's 33, then up to 37, all the way up July we reach the max. We go back down in December, and then the whole cycle starts over. And this is a sine wave. If I graph this, here's a graph of what the temperatures are doing. And it makes sense, right? In January, the temperatures are low. They go up to July. They go back down to January. They go back up, and this cycle continues. This is an entire sine wave period. And it's just like we did in class. It has a minimum line, maximum line, and a median line. The maximum line are the July temperatures, the minimum lines are the January temperatures, and the middle is just the average of the two. So whatever you can figure out the middle between the high and the low and draw that line in there. Then you can plot your points, draw a sine wave. All right, so how did I figure out those points? Well, step number one, the midline. Well, the maximum was 30, or the minimum was 33, the max was 85, sorry. Add them together, divide by 2, I have 59. So that's the middle of the data set. 59 happens in March, April. All right, so that can be put here. Well, how do I find the maximum, or the amplitude? Well, that's just the difference between the max and the mid, 26. So if you look on this graph here, this midline is 59, and if I go up 26, I'm up to the maximum at 85. And if I go down 26, I'm down to the minimum in 33. So that's how I found those numbers. And that gives you on this part of your graph here, or your equation here, and it gives you that part of your equation there. All that's left to find are the B value and the C value, and again, you will find those in Desmos. I'll demonstrate that in a separate video here in a minute, but you'll use Desmos to approximate those two. You have some other questions here. After you have your equation, you can find the temperature on the 4th of July. Well, July is the 7th month, and July 4th is the 4th day out of 31. So you can plug in this number, probably be best to convert it to a decimal, 7 point something, into this equation. And it will output 84 degrees. And then you look over here and say, does that make sense? In July, is the temperature about 84? Absolutely. Then Christmas Day. Well, Christmas is on December 25th. So 12 and 25 out of 31. Plug that in there, 33. In December, on Christmas Day, is the temperature about 33? Sure, that makes sense. And then put your birthday. Mine's December 6th, so I put that on there. Whatever your birthday is, put it on there. Plug it in. 35 degrees. Is it 35 degrees on my birthday? Yep, it's usually pretty cold in December. So this is the equation, and the reason why people have equations is so they can make these predictions about what's going to happen on certain days. So that's the overall basics of the project. Again, research data. Find these numbers on any city you want to. Pick cities around the world. Put them on a graph. Graph it. Max, mid, minimum. Plot the points. Draw a line. Do 2 periods. First period, second period. In this case, the periods are years, first year, second year. And then do the work to find the equation. Again, these are found mathematically. These are found using Desmos in the second video. All right, and after you make the graph, the the last part of the project is to show the work on Desmos here. These are all screenshots that I took from Desmos. Here's a table. You can input a table. Here's months 1 through 24, the first 2 years. Here's the temperature. It goes 33 up to 85, back to 33, and then the cycle starts over again. This is my scatter plot on Desmos. Here's all the points. First year to July, down to January, up to July, down to January. And then I put my graph in here that I made. It's never going to fit perfect unless you can find it to fit perfect. This was the best that I could do with it. And I'll show this in class and in the second video, but here's the equation that you write. Amplitude 26, midline 59, and you're finding the B and C. You use sliders in Desmos. These are sliders in Desmos. And you can move this back and forth and it will change this amount. You can move this back and forth and it will change this amount. And you just move it back and forth, trial and error, until you find a graph that fits. And that will be shown in the second video. All right, I hope this helps. For extra credit, you can do a maximum of up to 4 cities. It will be worth a maximum of 20 points depending on the quality of your work. It might be neat also if you can do a nice, neat job, put multiple cities on the same graph so you can see the differences between cities. Our temperature here in Huntington changes drastically compared to some other cities. So maybe if you looked at other cities, it might not change as much. Or maybe if you look at cities in the southern hemisphere, it might be flipped around. So have fun with the project, and if you have any questions, please email.